All right. So when you guys look here at your homework packet, I have the 3 major test topics written down there. These are our main building blocks that we want to get through in this unit. We have transformations focusing on vertical translation, the slope formula, and the distance formula using slope triangles and Pythagorean theorem. These are the main things that we're going to have to be able to perform on the test. And I really want to make sure that we understand all of this. So I'm going to take a little bit of extra time today. I'm going to kind of slow things down and ensure that we cover these things. I'm actually going to kind of go in a bit of a reverse order. I want to start with the Pythagorean theorem because I want to make sure that above everything else, we understand this. Pythagorean. Am I too high? Thank you. Okay. The Pythagorean theorem is pretty simple. All that it states is that if we have a right triangle, something like this. No, it's not my fault you showed up with no shirt sleeves. Okay. If we have the Pythagorean theorem where we have a right angle, what we're going to end up having is we're going to have 3 different sides to this. I'm going to call this A, B, and C. And when we have this, we know that A squared plus B squared will equal C squared. All right? And so using this, we can find the missing side if we have 2 of the others. So for example, I'm going to do a couple quick little examples here. Examples. Okay? If I had a triangle like this, where that was my right angle, and this was 8, and this was 5, and we didn't know what this is, we could take 8 and square it, add 5 and square it, and that will equal, in this case, our length of C squared. Okay? A, B. And it doesn't matter which one is A or B, because since it's just being added together, it doesn't matter which one's first and which one's second. It doesn't change the function. Like 5 plus 2 is 7 and 2 plus 5 is 7. It doesn't matter what order we go in. So this becomes 64. This becomes 25. This is our C squared. 64 and 25 is 89. And that's our C squared. So we know that the square root of 89 is our C squared. And I don't know what that is off the top of my head. And I do it on this thing. So if I do 89 and I square root it, it's approximately 9.43 equals C. Okay? Pretty simple stuff at this point. So that's one of the ways that we can do that. Yeah?
So now you want us to simplify?
Yeah, for a lot of these, it's going to ask you the distance, so you can go ahead and simplify it. I want you to be able to do both. I want you to be able to know that square root of 89 is 9.43 approximately. Okay? So that's one example of the Pythagorean theorem. I want to do another one. Okay? Because I might give you another triangle, like this. Except this time, maybe I give you the hypotenuse, a leg, and now we're missing a leg. Okay? So how do we do this? It's a little bit different. Now it's not the hypotenuse that's missing, it's a leg that's missing. Well, we got to plug it in the exact same way. So I know that 4 squared is my A. This would be my B, but I don't know what it is, so I'm just going to leave it as plus B squared. But I know 6 is my hypotenuse, so I can square that to get my answer. 4 squared is 16. B squared is itself. 6 squared is 36. I can subtract 16 from both sides. So that b squared is 20. When I take 20 and square root it, I get 4.47. So b is the square root of 20, or b is 4.47. Approximately. Okay. Let me scoop this up so you guys can see that. Okay. Can I clarify anything on this? Are we feeling pretty good on this? Thumbs up. Thumbs up. All right, Victor. I get this. I get these steps. Thumbs down. I'd like to see something else. I'd like to see more. Okay, just simple A, B's, and C's. Now, what ends up happening is we might be given something on a Cartesian plane. Okay? We might be given something on a Cartesian plane. So go ahead and draw your Cartesian plane. We might be given this. Mine's not perfect, of course. I'm just eyeballing it, but, good enough. Okay, we might be given something like this, and I might give you 2 points. Okay? I'm going to give you 2 points. I'm going to pick a couple points here. Let's say -3, 2. It's going to live right there. I'm going to call this A. Then B is going to live somewhere else. Let's say B's all the way over here. What is this? 1, 2, 3, 4, 5, 6. -1. Okay. So this is where we start to apply the Pythagorean theorem in a Cartesian plane system. So now we have A and B, and we might wonder how far apart they are. We might wonder how far apart they are. So something that I will certainly ask you is, what is the length of AB? What is the length of AB? Excuse me, I'm a little ill. Well, not terribly ill, but just annoyingly so. Okay, so how do we find this length? How do we find how long this is? So what we end up doing is we end up creating something we call a slope triangle. This is one of the methods. I'll scoot it over here. And so we'll say slope triangle method. Okay. Now the slope triangle method just asks us to look at this and try to determine what its slope is. And when we look at the slope, we're looking at the change in the y over the change in the x. And I see to get from 2 to -1, my y would go down like this. Okay? My y would travel down -3. And then to get from -3 to 6, my x would travel all the way over here. That would be the difference of 9, a positive 9. So in doing this, what I've done essentially is by looking at the slope, I've created a little right triangle. All right, I created a little right triangle where this complicated thing suddenly becomes a right triangle where I have the length of 3 and a length of 9. Okay, and you could see initially my slope movement was -3. But I wrote it as just a positive 3. Why did I do that? What was I thinking there? Yeah, Alessandro? I'm going to end up squaring it, so it won't matter in the end. Absolutely. And also, when we think about distance, anytime we think about distance, we don't really think about negative distance. There are some corner cases where we do, but we typically don't say, oh, you're going to have to travel, 2 miles to get to school and then negative 2 miles to get home, right? We don't think about distance in that way. But now that we have this slope triangle, we just simply do 3 squared plus 9 squared equals c squared. That becomes 9 plus 81 equals c squared. That becomes 90 equals c squared. So the square root of 90 is c. And 90 square rooted is about 9.49. Yes? Okay, so why did I write positive 3 instead of negative 3? When I square, it's not going to matter. And also when we think about distance, it doesn't matter either. So what I'm doing here is it wouldn't make sense if I had a triangle. If I gave you a physical triangle and I said that the side of this leg is negative 3 feet, that wouldn't make any sense, right? If I were to give you this ruler and say that it's negative 1 feet long, you would say that doesn't make any difference. It's 1 foot long. So when we're talking about real world lengths, when we're talking about how far things are, those negatives just get lost. They become absolute values. Okay? Now, it doesn't change the math at all. If you wanted to use this and have it be negative 3 squared plus 9 squared, well, negative 3 times negative 3 is going to be positive 9, and then 9 is going to be 81. So we end up at the exact same step anyway. Okay? So after doing all this, we know that AB is going to equal 9.49 using the slope triangle method. All right? Questions on this so far? Feeling good? Feeling frisky? All right, moving on. Hello. All right, so we're going to do this the other way now. All right, we're going to do this a different way. Now, instead of the slope triangle method, we're going to use the distance formula. And so the distance formula, we don't need to have a physical rendition of what's going on here. It can just be the 2 points. All I need to know is that point A is negative 3, 2, and point B is 6, negative 1. That's all I need for the distance formula. Because the distance formula states that our distance squared is going to equal the difference of our x's squared plus the difference of our y's squared. Okay, the difference of our x's squared plus the difference of our y's squared. So that's going to be x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And so all that this is a very algebraic way of constructing a slope triangle. That's all that it's doing, is instead of physically drawing it out, writing a 3 and a 9 and counting, we're just doing it through algebra. We're doing it through substitution, in fact. Because when I look at this, I'm going to say A is my first point and B is my second point. I decided to do that because that's how it works in the alphabet. So I'm going to say d squared equals x2. So x2 means the x value of my second point. B is my second point. My x value is 6. So that's going to be 6 minus the x value of my first point. The x value of my first point is negative 3. So 6 minus a negative 3, I'm just going to say that's 6 plus 3. And that's going to be squared. Okay? 6, negative 3. Just like that. Okay, these are my x's. 6, negative 3. Just like that. So then I need to account for my y values. I'm going to add the y value of my second point, which is negative 1 here. This is my y2. So I'm going to say negative 1. And I'm going to subtract the y value of my first point, which is 2. I'm going to square that. Okay. Does everybody understand how I found x1, y1, x2, y2? Okay. It's just like making a recipe. Okay. You want your cup of noodle. It says add a cup of water. So you got to go get water in a cup and put it in. And then you've got to microwave for 30 seconds. You've got to press all the buttons and you're good. Okay, same thing. So this becomes 6 plus 3 is 9. Okay? And we're going to square 9. Negative 1 minus 2 is negative 3. So plus a negative 3. And we're going to square that. Okay. And what I want you guys to see is that this here is exactly the same as this here is exactly the same as this here. Okay. So pretty much what we have done is we have just constructed a slope triangle through algebra without actually having to draw the triangles. We're just using this abstract way of communicating to represent this image. It's kind of like, we do this in language all the time. We have representational words. When I say the word cat, your brain thinks of a furry creature with whiskers and a tail and somewhat pointed ears that sometimes likes to wake you up in the middle of the night and cry for food. And then you come to work a little tired, a little bit sick because you didn't rest very well, but then you forgive it because it's cute. But yeah, when you say cat, you think of all of that.
I think of sharks.
You think of sharks when you think of the word cat.
Sounds a lot like a mouse.
Really good.
Anyway, that's what we're doing here. We're just doing it through numeric communication instead of geometric communication. So when we do this, sure enough, d squared equals 81 plus 9, which will equal 90. So d equals the root of 90, which is roughly 9.49, just like we found out before. You know, both paths lead you to victory, okay? Whether you walk to the grocery store, whether you get on the bus and go to the grocery store, whether you fly to the grocery store, you're going to the grocery store. You get there. You get the answer. It doesn't matter which path you choose, but you got to make sure you're choosing a path. Okay? So that is all of that. So let me double check the test topics real fast, okay? Distance formula. We've talked about slope triangles and the Pythagorean theorem. Or we've also talked about the distance formula, d squared equals y squared minus y1. Yeah, okay, cool. So I feel like we've accomplished this much. We have this in our notes. We're going to be prepared for the test. We at least have this here. All right. Next, slope formula. Do we need to go over this one in much depth? Do we know how to calculate slopes? We feel okay with this one?
Yes.
Okay. You know, in case you don't, we just did it here. This 3/9. This becomes negative 3 over 9. We could reduce that to negative 1/3. We would say that this is our slope. Okay? Just a quick little review. I feel like we've hit this one to death. So the final thing that we really need to talk about is transformations. And the thing that we're talking about the most is vertical translations. All right, so let me go ahead and grab a new piece of paper for this concept. So you have the concept of vertical translations. And what we have is we have this thing that we call translation form, where some g of x is going to equal an f of x plus k. All right? So what's going on here? What do all of these mean? Well, I'm going to use some of the language that we've used in previous lessons to help us understand that. So f of x is our original function, otherwise known as the pre-image. Okay? F of x is the OG. G of x is our transformed function, right? It's the robot in disguise. It was once a semi-truck, now it is a fighting robot from, I don't know what planet they're from. Otherwise we call this the image. Okay? This is the new guy, transformed. And then finally we have K. No. K is the vertical translation. Okay? It's how much, I need to scoot that up. It's the vertical translation. It's how much we need to actually move the gosh darn thing. Okay? So when I'm looking at a line, I'm just going to draw a very crude Cartesian plane here. Okay? And let's say I had f of x equals, we'll say 1/2 x minus 1. Okay? So now I have to graph that function. I go down 1. My slope is 1/2, so I go down 1 over 2. So I end up with a line that looks a little something like this. That is my f of x. Okay. Now let's say I then had g of x equals f of x plus 4. Well, what does that mean? Well, g of x is my transformed function, and there's this plus 4 here. That plus 4 is the k. Plus 4 is the k. So that means that has to be my vertical translation. So I have to take my f of x and vertically translate it plus 4. So I go up 1, 2, 3, 4 to here. And likewise here, 1, 2, 3, 4 to here. I have 2 points. I can now draw my g of x. And it looks a little something like that. Okay. Does that follow? And so we can do this translation whether or not we're given the equation, whether we're given the image, or whether we're given the table. Any questions on this? You guys want to see a table to see how it works? Do you feel like we got it? Okay. So here's what I want from you guys today. I want you guys to work on the homework that we did yesterday. If you are done, I have some drills I want you to do. And I'll go ahead and stop the video, and then we can discuss all of that.